we are going to look at our next example here. Example 8.5. Okay. So we are looking at an inelastic collision now. So remember that an inelastic collision is going to be where my kinetic energy, my initial kinetic energy is not equal to my final kinetic energy, or it's not conserved. Okay, not conserved. Okay. Now, we want to find the recoil velocity of a 70 kilogram ice hockey goalie. So our mass is 70 kilograms, who is originally at rest. Okay, so our V2 is 0. Oops, 2. Okay. And he catches a hockey puck with a mass M1 equals 0.15 kilograms. Okay. That has slapped him at a velocity V1 of 35 meters per second. Okay. So again, we want to know the recoil velocity. Okay. So first of all, we need to define what recoil velocity is. Okay. That is going to be our final velocity. Okay, so we want to know our V prime. What is that? Okay. So, let me go over here. And remember that momentum is going to be conserved. Okay, so momentum conserved. Okay, so that tells us that P1 plus P2 should equal P1 prime plus P2 prime. Okay. Now, we do know that our second velocity is 0 meters per second. Okay, for our initial, for our hockey player here is 0. So this P2 is actually 0. Okay. Now, one other thing to notice, let me see. You can see it in the graphic that my initial velocity, or I'm sorry, my velocity of the puck initially, right, is going at some speed V1, and then the guy stops it, okay, and they both get pushed back with some velocity. Okay, so that's the velocity that we are trying to find here. Okay, so we just want to keep a reminder out there for that. Okay, so let me go ahead and plug in or rewrite this as M1 V1 equals M1 V1 prime plus M2 V2 prime. Okay. So we notice that our velocities should be the same here. Okay. So that means that this can actually be written as M1 V prime plus M2 V prime. Okay. Or M1 plus M2 V prime. Okay, and since we know our masses and we know our velocity here, we can go ahead and solve for our velocity, our final velocity, or our velocity after the collision. Okay? that will be m1 v1 over m1 plus m2. Okay, so that should be m1 is 0.15 kilograms times v1, which is 35 meters per second, over 0.15 kilograms plus 70 kilograms. Okay, so you can go ahead and plug that into your calculator. And you should get a velocity of 0.075 meters per second. Okay, so they, if you think about this, if you've ever watched a hockey game, maybe some of you have, maybe you haven't, but when that hockey puck is coming in and hits the goalie, he doesn't really move a ton, but he might move a little tiny bit. And so that's what you're seeing here, that little bit of velocity that was left over, okay, after that collision, okay? All right, so that's for the first part. Now part B, how much kinetic energy is lost during the collision? Okay, so what we're gonna do is we're gonna need to find the kinetic energy before the collision and the kinetic energy after the collision. Okay, so again, this is an inelastic collision, so kinetic energy is not conserved. Okay, so let's go ahead and do this. So we should have some kinetic energy of the first plus the second initially, and then after the, oops, not squared, prime. Okay. Now our kinetic energy of our second mass is 0, right? Because kinetic energy, how you calculate it is 1/2 mv squared. And if our velocity is 0, right, the whole thing would be 0. Okay. Now, we did find out that our velocity on this side, okay, I'm sorry, this should not be equal to each other. It's not equal because it's not conserved. But I'm just kind of comparing the two. So let's go ahead and focus on the before. So our before, then our K tote is going to be just K1. So that's going to be 1/2 M1 V1 squared. Okay, so you can plug your values in. M1 is 0.15 times our V1, which is 35 squared. And we get 35 squared times 0.15 times 0.5, 91.9 joules. Okay. Now our after collision is going to be K1 prime plus K2 prime. Okay. But remember, our velocity is the same. So we can either write it this way, M1 V, oops, V prime squared plus 1/2 M2 V prime squared. Or we can just write it as 1/2 M1 plus M2 V prime squared, whichever works for you. And then we get 1/2. That is going to be 0.15 kilograms plus 70 kilograms times V1 or V prime squared, which is going to be 0.075 meters per second squared. Okay. So we should get 5 plus 70 times 0.075. Oh. Get 0.197 joules. Okay. And if we want to calculate, we're calculating the difference or the lost amount of kinetic energy. That's so weird. That is going to be K, I'm going to say lost, okay? And I'm going to start with my initial. It's going to be 91.9 joules minus my final amount here. That is going to give me about 91.7 joules of kinetic energy lost. Oops. Okay, so hopefully that made sense and wasn't too confusing. Okay. All right, so that is going to be the end of this video, and I do have a few more examples that I will go ahead and post.